Okay, let's do some partial product multiplication again. But this time we're going to extend our multiplication instead of doing a 2 by 1 multiplication problem like we did previously, say 21 times 8. We're going to extend it to 2 by 2 digit multiplication. So a multiplication problem such as 21 times 34. So there's a couple ways for us to do these. Let's erase real quick and let's actually do 21 times 34. That seems like a good starting problem. So let's do 21 times 34. And one of the ways that we can do this is the way that we remember doing it when we did it with a 2 by 1 digit, which was using a partitioned rectangle. So I'm going to draw myself a partitioned rectangle here. You might call it a partition square. Okay, and I'm going to partition this rectangle just like I did when it was a 2 by 1. So here we have the number 21, and we know 21 is really just 20. Let me erase that. It's really just 20 plus 1. So if I were to partition right down the middle, I would put my 20 here and my 1 here. Well, now we have a problem that we haven't seen before, because now we have 34 and we think to ourselves, well, 34 is really 30 plus 4. Well, normally when we had a problem such as 21 times 7, for example, we would just put our 7 right there and that was it. We were done. But now we have 2 digits. So we got to think about what could we do to decompose and partition this square for our 2-digit number. Well, what you're going to do is you're going to partition it in half horizontally. And we're going to put our 30 here, and we're going to put our 4 here. And then we just do the multiplication. Well, 30 times 20, that's going to be 600. 30 times 1, that's going to be 30. 4 times 20, that's going to be 80. And 4 times 1, that's going to be 4. And what do you do with all of these numbers? Well, you simply add them. So we're going to take 600 plus 30 plus 80 plus 4, which gives us an answer of 714. So if we did 21 times 34, that will give us an answer of 714. So that's using a partitioned square or a partitioned rectangle, whatever language you prefer to call it. We can do the same process. So let's write it again. Let's write 21 times 34, but we can make it a little bit faster. We can take this partitioned rectangle out of it by thinking about just the partial products themselves. So just the partial products. So what are the partial products? Well, that's the value of the digits depending on their place value. This should look familiar. So once again, we know that this 2, well, that's a 20. And this 1, well, that's just a 1 because it's in the ones place. 2 10s, that's 20. Okay, 3 10s, well, that's 30. 4 1s, that's just 4. So we have our partial products. So these are called partial products. Once we multiply, we will have our partial products, I should say, excuse me. So let's do our multiplication, okay? So we're going to do 30 times 20. Well, that's 600. Now we're going to do 30 times 1. That's 30. Then we're going to do 4 times 20. Let me get a different color. We're going to do 4 times 20. Well, that's 80. And then we're going to do 4 times 1. That's 4, which gives us an answer of 714. So these, excuse me with my language earlier, these are the partial products, okay? This is just the value of the number in the place value. So this 2 is worth a 20, this 1 is worth 1, the 3 is worth 30, and the 4 is worth 4. These right here, these are the partial products. Okay, and you'll see the same exact answer as we have over here from when we did our partitioned rectangle. As always, happy learning, and I'll see you in the next video.